Hello everyone, and welcome to today's webinar with Tamturbo. Just a couple of housekeeping points before we get started. There will be time at the end for a Q&A session. You can ask a question using the box under the slides. This is private, and we'll get to as many as we can at the end. You can also use this box to let us know if you're having any technical issues, and we'll do our best to help you out. And with that, I'll hand over to Olli for the presentation.
Thank you. Very nice that you are here to talk with me or see the presentation on the savings in the compressor room. I actually changed the title from a question to an exclamation because I know that all of the participants will have savings available in the compressor room. So it's not a question of if, but where and how. In the end of the presentation, I'm hoping that first of all we'll have questions and I'll be able to clarify anything that wasn't clear. But also I would really appreciate it if or like that you have found that there is a newer technology that offers significant monetary savings as well as improved sustainability in terms of ecological sustainability. Also, that you would know that there is a technological shift happening that already actually started in the base technologies a couple of decades ago and is now taking place in the compressed air world. And one of the things that we hear a lot, that this sounds too good to be true, that you would see that it's not too good to be true. It's good, but it's also true, and it's proven in real customer cases. So my name is Olli Kuismanen. I'm responsible for global accounts and partnerships at Tamturbo PLC. I'm an engineer by background in power electronics and business school, and luckily all of my employers have found less dangerous things for me to do than work on power electronics. So have been working in different industries in business development roles my whole career. So do please write questions as they come along. I may pick them up if it's related to that topic, or then I will have handled them all in the end. So a few slides about Tamturbo. Tamturbo is a company that is targeted towards only this one single purpose. We develop, manufacture, and sell industrial turbo compressors, which are 100% oil-free, meaning that there's not a single drop of oil in our compressor, which is not the case for actually all of the other compressed air solutions on the market. We are the most sustainable solution on the market in terms of economical sustainability, so money-wise, and also, as I said, from a, let's say, ecological or climate sustainability and those issues as well. As said, with the lowest total cost of ownership of any compressed air solution, especially compressed air solution which is of variable flow. We were founded in 2010 by a few gentlemen, one who had 40 years of experience in oil lubricated and in the, let's say, traditional compressor technology, and then another gentleman who had been working for decades on the high speed motor technology and active magnetic bearing technology, and they realized that it will be financially feasible and technologically feasible to make this transition in technology for the big compressed air, let's say industrial compressed air market. The first 5 years we did mostly R&D, delivered our first unit to a paper mill in 2015, and then that unit has been there operating ever since. Really launched for the global market in 2017. 2019 we launched a few more products, and actually this year, which is not shown on the slide, we had a very important milestone a couple of weeks ago when we got Sulzer, a Swiss company Sulzer, as one of our shareholders, and also we have been cooperating with them for quite some time to bring this technology to their customers in their selected customer segments as well. Sulzer, as you may know, is a large industrial equipment and service provider, very strong in pumps, low pressure compressors, which is actually, let's say, a sister or brother to our medium pressure compressors in terms of technology. So it's very good partner to have on this journey. And quoting the movie Jerry Maguire, where it says "Show me the money." So here is where the money is. On average, industrial compressed air consumes 10% of the electricity utilized in the industry. It's an amazing amount of electricity that is used just to put air in a lower volume. It's actually 5% of the world's total electricity consumption. And the money is really there, that 97% of this energy is in traditional solutions lost, or in most cases lost. We can save 10% of that 10%, so 1% of the total electricity consumption for oil-free air. You don't use that 1%, and then through our heat recovery systems, we are able to help you use that other part of the electricity, or most of that other part of the energy in your process, if you need and can utilize hot water in your process. So this is really where the target is to reduce the amount of energy wasted in compressed air. The reason why 97% of the energy is wasted, or let's say it's a lot of waste in compressed air, and still compressed air is used, that it's very safe way to transport energy from place A to place B. So you can use the energy in the compressor room, and it's very safe to convey that energy to the actuator or robot or whatever machine that is using the compressed air, as it is safe for people. It's safe if it leaks, it is safe to touch, and so on. And the industrial automation growth means that the compressed air usage is growing quite rapidly, and the oil-free compressed air usage is growing much more rapidly. Traditionally, compressors were done so that, let's say, in 70% of compressors, there is oil in contact with the air, and 30% of compressors or compressed air is so-called oil-free. And oil-free compressed air is mostly used in industries where you actually just cannot have any oil in the air, because it may come into contact with the end product, for example, food and beverage, pharmaceutical, electronics, automotive, where painting, or anywhere where you want to have quality painting, you cannot have anything in the air that destroy the paint quality. And pulp and paper is fairly big in a big user of compressed air. And traditionally, this oil-free compressed air needs has been let's say, met with the so-called oil-free dry screw compressor, and I have the oil-free in these quotation marks, because the compressor is really not oil-free. The yellow part, which you see on the picture on the top left, that is actually the gearboxes and the oils. And when the unit operates, oil vapor exits the compressor, and then if you suck the compressed air or air for the compressor from the compressor room, then you have oil vapor in the air, and then you will have oil in the resulting compressed air. And the other way is that the other risk, which actually happens surprisingly often, is that the only thing separating that yellow oil from the gray screws, which is actually doing the compression by rotating, is a shaft seal. So that shaft seal leaks, you get the oil in the screws, and then you get the oil in the compressed air system, in the pipes, in the filters, in the dryers, and so on. But the oil is actually it's a small problem. It's a problem, but it's a small problem compared to the screw, let's say, screw coating. So those gray screws, there's two pairs of screws, each having a male and a female part. They rotate and they push the air forward, which then compresses the air in two stages. Those screws are coated with a PTFE, so Teflon-like coating, to make it as airtight as possible, to make the air gap as small as possible in between those two screws. And the problem is that as soon as you start to rotate those, and they're especially if you are using the compressor in an on-off manner or fluctuating load, then those surfaces start to touch each other, and the Teflon starts to wear. And this efficiency loss, of course, causes you more electricity consumption, and at some point it causes the need to overhaul or in most cases replace the screw elements, so the actual parts that are touching the air. And this coupled with the very high maintenance cost of the compressor in general gives it a very high maintenance cost over its lifetime. Typically, around 4 to 7 years is when you do the overhauls, and of course, every 4 and 8,000 hours, you have to do the oil changes, and then you have to change the bearings and so on. It's a very high maintenance intensive technology, which is of course good for the manufacturers because they make most of their money on service. This is their highest profiting part of the oil-free screw compressor business. Our solution is then on the other extreme. Ours is first of all 100% oil-free, so there isn't a single drop of oil in the compressor, and we do that by magnetic levitation. I'll explain that in a little bit when we go a little bit further. This means that there is no metal-to-metal contact of the moving parts in our compressor core, which means that it is maintenance-free. So we have nothing to maintain on the compressor, on the core unit of the compressor. So our solution is very different from the old, let's say, legacy technologies, which is very good for these industries where they need oil-free air, but don't want to pay a huge amount of for electricity and don't want to pay a huge amount for maintenance. And this is let's say the core of our touch-free technology. No more audible, please check. Have I lost audio? Khalid Saifullah is saying they can't hear me.
I can hear you, Olli. You're coming through loud and clear on the auditorium. I'll get back to gentlemen.
Okay, thank you. So the touch-free technology is centered around a high-speed electric motor, which is there in the middle. So it's a permanent magnet electric motor, pretty much similar to the induction electric motor from a working principle. The gray part in the middle is the rotor, and that rotates typically up to 35,000 RPM speed. And directly at the end of that rotor, that spinning rotor, are the turbo impellers. So number 2 on the picture. In this picture, in this cutout picture, we have an impeller on both ends of this one motor, and the impeller is sucking air in where there is the number 4, and then giving it a high speed, and this high speed then is turned into pressure in the volute in number 5. And this whole package, so the rotor and the impeller, is levitated in mid-air by so-called active magnetic bearings, which are measuring the position of the rotor several tens of kilohertz frequency, so several tens of thousands of times per second, to the accuracy of micrometers, and then as it fluctuates or goes into either in any direction from the center, it actively pulls it back into the center by using a current in a coil. So this is something that keeps the rotating, very high-speed rotating rotor in typically in 10 micrometer distance when it is rotating. And I will come back to it, but this technology has already been used for several decades. The first commercial application was launched in 1976, and it actually originated already after the Second World War for plutonium enrichment, also for centrifuges. and it has been used successfully, for example, in this low pressure wastewater aeration, low pressure compressors or blowers, already for decades, with units on the field for more than 25 years, with practically no maintenance during the life cycle of the product. And this is actually the same technology that is used, and the same motors that are used when there's a gas pocket under the sea, and you want to lower a motor there to pump the gas, the natural gas out of the seabed. You don't want to go there every 4,000 hours to change the oils or do maintenance on the unit. So you use the most reliable technology for that purpose, and now we are using that technology for the industrial compressors. So this is the core technology in our compressor, and then when we add multiple motors, in this case for up to 9 bar pressure, we use 2 motors, and then having multiple compression stages. In that picture, we have three stage compressors. So the biggest, let's say, the open pipe in the center is the first stage, and then we cool the air after it comes out of the first turbo by a heat exchanger, and then the second stage is on the other end of that same motor, and the third stage is on the second different motor, smaller motor, and this creates the compressed air for the customer network, let's say from 2 to 9 bar range. And this slide is about efficiency in compression. So as I explained, when there's no metal-to-metal contact, there's no losses because of bearings, because of anything else. Nothing else is being affected by the spinning rotor and impeller than air. So it's very high efficiency rotation. It's also because of the precision, the air gap between the rotating impeller and the so-called volute, the turbo head, can be very small. So the compression is very efficient. But in addition to that, for customers who can utilize heat, water-cooled compressors have been around even for the legacy technologies for decades. But for the most cases, the amount of heat that is recovered is very low. For us, it's up to 93% of the electrical, let's say the wire energy that is taken from the electrical grid. So 93% of that we can get back in that hot water, which is in the red pipe at the bottom. And the other thing is that the outgoing water can be up to 90 degrees Celsius, which means that for customers who are using our compressor, they can really utilize this 90 degree or 70, 80, 90 degree water in their production. Whereas for the legacy technologies, the amount of heat in the water is less, and the temperature of the water is typically much less. And we do this by very well optimized heat exchangers, and also we are using a closed loop internal cooling, where we take the heat from the electrical motors, the turbo heads themselves, which get quite hot when air is compressed, and then also the inverters are water cooled. So we are taking every bit of energy that we can from the compressor, and the customer can then utilize that hot water in their process. So we can say, jokingly, we can say that you can use the compressor to heat water, and as a side product, you get the compressed air that you need. So this is one part of the let's say the sustainability, and also one part of the life cycle cost that we are talking about. So most importantly, 100% oil-free air for the production, which means the actual production quality, the real production that the plant or facility is doing is high quality. What is very important is that in most cases, and actually in all cases in industry, the amount of compressed air needed at a given time is not fixed. It's variable. And through our VSD turbo, we can have literally the same efficiency at the full load and at the half load. And so the efficiency of the compression is not dependent on the let's say the loading of the compressor, which is not true for the other technologies. Energy efficiency, it's a better energy efficiency, and most importantly, it's a lasting energy efficiency of the compressor. So it doesn't start deteriorating as soon as you use it. It doesn't require you to spend more money to try to keep it efficient. Reliability is of course important because most of the processes that use compressed air in manufacturing, they actually need the air whenever that process needs to take place. So it's not an option that the compressor wouldn't be up and running. Traditionally, with the traditional technologies, this has been solved by redundancy. So there might be a need for, let's say, as a ballpark, there might be a need for 3 compressors flow. But the facility might have 5 or 6 compressors because the compressors, traditional compressors, they need a lot of service. So there's a service downtime, and then there's some unreliability in those technologies that require a huge amount of redundancy in the compressed air plant. And I said the extra value of the energy recovery, then it blows the let's say the energy efficiency discussion to a whole new level. About the money again, the lowest total cost of ownership. On the top left, you see the different parts. What does the total cost of ownership of compressed air? What does it mean? Where does it come from? The tallest bars, which are the darker blue is Tamturbo, the lighter blue is a so-called oil-free screw compressor, and then the gray one is the oil lubricated compressor, the very traditional screw compressor. The energy cost of the energy is the biggest part of the cost of using the compressors. And of course, when in our case we are more efficient and more importantly even the lasting efficiency, which is shown on the center in the bottom with the shark fin type of picture, where our efficiency stays the same throughout the life cycle of the unit, whereas the screw compressor starts to deteriorate, and like I said, between 4 to 7 years, typically 40,000 operating hours is the latest time when you need to then do the overhaul. So you try to get the efficiency back up. You don't get to 100% actually ever, and then you start using it again, and it starts going down. And this is then depicted in the service and maintenance columns on the top, where practically we can save 90% of the service cost compared to the oil-free screw compressor. Much less than even the oil lubricated compressor, which as such is quite efficient, but then the efficiency is lost on the filtration of the oil and also on the service cost related to the oil content in the compressed air. From the purchase cost, we are typically on the same level or slightly higher in some cases than the oil-free screw. But what needs to be noted that even if you would get the oil-free screw compressor for free, you shouldn't take it because you lose more on the service and maintenance and energy than whatever differences on the purchase cost. And if you can then, because of the better energy recovery, you can then utilize the heat, then you can discount that whole energy bar from our solution, which is the typical case that this is in many places this is the first compressor where the energy is actually taken into use. In most other compressors, it is blown to the sky with a cooling tower or dry cooler. That being said, it's not only about the energy recovery. Here's an example of from a customer, a real life case study where they did a measurement of the compressed air efficiency before our compressor. There used to be 3 compressors of the so-called oil-free screw compressors, and then they did the same measurement after or during when our compressor was put into use. Okay, the country is having a quite high electricity cost, so 14 euro cents per kilowatt hour. But even if you do it with 7 cents, there's still I think about 64,000 euro bottom line annual savings. So what this is saying that the customer uses 22 million cubic meters of compressed air in a month. No, sorry, this is a year. In a year. And previously, the efficiency of the compressors was 0.14 kilowatts per cubic meter. After the change, with our more efficient compressor taking a bulk of the load because of the good variable load characteristics, then the same amount of compressed air was done with almost 500,000 kilowatt hours less energy. This is directly then as a cost saving 64,000. The other part is that they used to spend 52,000 euros for maintenance of these 3 compressors. And in the end, with our extended warranty, which I'll talk a little bit more about in the coming slides, they were able to only maintain one of the old compressors, which wasn't used that much, and then they had our extended warranty on top of that. So 85,000 euro savings for a compressor that doesn't cost twice that much, direct savings. And in addition, there's other savings then down the line in the drying and filtration and maintenance of those equipment. As well. So it's not only about the compressor itself, so the boxes on the top left, it's also about the systems that are coming after in the compressed air line. So the filtration, especially with processes that need dry air, so pressure dew point -40, which means a desiccant dryer. The difference between our compressor and the legacy technologies in the maintenance cost of the dryers is significant. And what is most important is that the quality of compressed air to the production is much higher. So the quality of the production is increased by a more stable compressed air network. You'll have access to these slides later on. You can look at the details of this slide. It's a fairly busy slide, and we need to move forward. Please ask questions if you have them. As a short summary about why Tamturbo technology, at least I pressed the next slide button. It should be turning. Okay, now it went to. The sustainability is of course the one part. So better and lasting energy efficiency, 100% oil-free air, and also reducing harmful waste from operations. The oil waste that is generated by the legacy compressors is something to be taken into account. Reliability, nothing wears, so practically no maintenance. Wide turn-down range with high efficiency, meaning that the compressor can go 100% and it can go 50%, and the efficiency is linear. So it uses 50% of the energy in 50% load or flow, which means improved operations and product quality. And then the one on the right is that the oil-free market has been dominated by only a handful of companies, and they have really taken their benefit from, especially from the service of the oil-free screw compressors, oil-free compressors, and customers are really getting fed up with this type of model. And now that we are offering this type of alternative, they are quite keen to get on board. As said, this already happened in the low pressure market, which you can see on the top there. Since the 90s, the high speed blowers started to take the market from the screw and lobe blowers and compressors, and now the same is happening with the industrial medium level compressors, so from 3 to 9 bar range, and we are pretty much the only one actively selling this technology at the moment. A couple of other compressor manufacturers have this technology in-house, but they don't want to sell it because they don't want to jeopardize their service business, which has been in compressed air world the way to make money. So kind of like a Gillette type of approach, that you sell the compressor, and then where you make most of the money is on the service and the spare parts. And in our case, we do sell the compressor, and we do sell the few spare parts and consumables like the inlet filters and so on. But that is not our business model. Our business model is more in the investment and extended warranty, where we actually guarantee a fixed annual fee for all the maintenance and all the spare parts, all the consumables related to the compressor, so that as a customer, you know that you will not pay a single cent or dime more than that that money for the compressor. And we can do that because all of our units are remotely monitored, so they all have a modem, a 3G modem, 3 or 4G modem in the unit, and our technical support team is keeping an eye on the compressors and actually optimizing the compressor usage if there are production changes in the factory. So they are always optimizing how the compressor is operated remotely, unless the customer, of course, says that we cannot do it, but we can. If they allow us. And then the other thing is on the bottom, touch-free air is our air as a service model, where actually the customer doesn't need to own the compressor. We own the compressor, we operate and maintain the compressor, or we maintain the compressor, and the customer uses only the compressed air, which then we can charge them by month or by cubic meter basis for that service that we provide. This is becoming increasingly interesting also in these let's say capex tight times at the moment. And it's not a decision that you ultimately have to make for the rest of the lifetime of the unit. We can start renting or start providing the touch-free air service, and then later on we can convert that into a sale if the situation so allows. We already have operations in most parts of the world from a let's say longitude perspective. So from Asia, Southeast Asia, Middle East, Europe, and then of course Europe and North America being our strongest markets. We operate in different ways in different parts, and as mentioned before, we have now a good big brother beside us with Sulzer, having a presence in most parts of the world, and the capability and the interest and the commitment to serve the customers with the same technology through in their own brand. A couple of examples from customers. So we have a lot of customers in food and beverage, whether it be one of the world's largest brewing companies who's having units in sugar and sweets, or let's say sugar and chocolate factories, food in meat processing, in different types of food processes. Pulp and paper is quite big, where we have customers who actually have units in multiple factories in different continents already. Foundries, glass companies, electronics is one place where air quality is very important because of the production cleanliness need or need to have zero contaminants in the production area, and you don't want to push in contaminants through the compressed air. So quite a few examples in different industries around the world already. I think I'm just about done with the time. It's now time to say thank you very much for your attention. There are a couple of questions on the list. I'll take them briefly, but in case you get questions afterwards, you can always contact me. There's my email address and cell phone number, and of course our website is also available for more information. There's a couple of questions on the list already. One question regarding the electricity. What is how sensitive is the compressor to power fluctuations, and what happens in a power outage? So this is actually one of the most frequently asked questions. I will jump to this slide. Hopefully the system will allow me. So what happens if the power gets cut? And this is actually something that we test for all units, and we have done extensive work on this. And then also on the field, we've had dozens of compressors experience a power outage while the compressor is in operation. What happens is that this motor, which is a permanent magnet motor and it's spinning quite rapidly, it turns into a generator. So as soon as the power goes out, the motor starts to generate electricity, which is then fed to the active magnetic bearings, so that we always keep the levitation. So we always keep the rotor in the center, even when the network power is off. And this happens all the way through to the point where the motor stops, and then it lands on we have this backup elements, mechanical elements there also as well to safeguard the unit. But that is clearly a non-issue for this technology. Then there's a high, what is the ambient temperature? So our standard ambient temperature for the compressor is 35 degrees Celsius. We do deliver up to 45 degrees Celsius with a slight technical change. And then if it is even hotter, we can deliver based on the specification also a hot ambient version where actually there's a cooling device beside the compressor. Of course, in hotter temperatures, the compressor, the air compression itself becomes less efficient, but that is the same for the other compressors as well. So we can deliver higher temperatures with a slightly longer lead time when this is needed. And then there's a question in the example number 3, the company. I'm guessing that has to do with the references. Let me dig that slide up. Okay, sorry, I had to expand the question. In the example 3, the company replaced an oil-free or oil-lubricated compressor. So you mean the case study? This was an oil-free compressor. So this example was an oil-free, so-called dry screw, oil-free screw compressor that was replaced. What is the minimum maximum productivity in cubic meters minute of your models? So the smallest model, if we're talking about the medium pressure range, so up 5 bars and up, the lowest cubic meters per minute is about around 10 cubic meters per minute, and the maximum, the biggest model TT325 is at 7 bar 52.1 cubic meter per minute, if I'm not mistaken. So from 10 to 52 or 53 is the let's say the area. So in kilowatts, that means somewhere 70 kilowatts to 350 kilowatts of package power. Then there's a question about the maintenance schedule. What is the maintenance schedule like? Well, actually, we don't have a maintenance schedule because none of the maintenance operations are done based on time. So the compressor measures, for example, which is the most frequent maintenance item on our compressors, is changing the inlet filters. We are measuring the pressure difference over the inlet filters, and when the compressor sees that the filters are getting clogged, it sends an SMS message as a, let's say, first warning message that recipients of this SMS message, please, I need new filters. And then also through our technical support, they monitor the situation, and we can schedule for example, the filter change based on the production needs of the factory. It actually takes about 8 minutes to replace the filters, so not a big topic. All right, then there's a question: what is about the wear metal contaminant? How high is possibility of cooling water contaminant compressed air during cooling process? How high is possibility of cooling water contaminant? Okay, the cooling water doesn't get it's not in contact with the air. So the cooling water only is contacting the. Let me dig that picture up. It's only on the heat exchangers, on the other side of the wall to the air, and then also for the turbo heads, it doesn't get in contact with the compressed air. So from the water, there's no contamination to the air, and of course, the cooling waters itself, it can be fresh water, so you can use the factory fresh water and then get the heated water for the heating of the building or showers or canteen or whatever, or you can use a closed loop. We can have a closed loop circuit here if you are using, for example, river water or something else to cool it. I hope that was the question. What is the maximum pressure range of compressor? Depending a little bit on the model. Let's say we have 2-stage models where we only then have one motor and these 2 stages that you see in the picture, and the second motor is missing or not there. Those 2-stage models are from 2 to 5 bars. in certain models 2 to 4.5 bars. And then the 3-stage models are up to 9 bars, or in certain models up to 8.5 bar. We actually have done 12 bars with certain models, but the higher you go in the pressure, the less control range we have for the compressor. So at 9 bar or beyond 9 bar, we cannot have very fluctuating compressed airflow. But let's say in normal situation, in normal practical factory situations, the 6 to 8 bar, we have a significantly big turn down range. Thank you, Thomas. It seems that Tamturbo is competitive solution against oil-free compressors. Is it competitive against typical oil lubricated compressors? From a cost point of view, yes, it takes a little bit longer for the, let's say, the payback of the compressed air quality comes in a slightly different way. We do have multiple customers who have traditionally used oil lubricated screw compressors. So the energy efficiency of the compressor itself, the oil lubricated screw, is quite good. But when you take into account the added pressure drop of the oil filtration, then the energy efficiency difference is we are in some cases actually better in energy efficiency before the dryer. But then when you take into account the amount of maintenance needed for the desiccant dryer for the oil lubricated compressed air compared to our compressed air, and when you take into account the maintenance of the actual compressor of the oil lubricated compressor and our compressor, then in a typical case, around 4 to 7 years is where we then start being a fair bit more competitive or less expensive than the oil lubricated screw. But that being said, it's not our main market. Our target market is the oil-free market. And even though, especially for the touch-free air, we have customers who used to or who typically use oil lubricated compressors in a touch-free air. So our air is a service model. Then that is quite let's say there we have a match. We don't have too many customers who have bought our compressor if there's no need for any oil-free air. Depends a little bit, of course, on the local maintenance cost and let's say how relevant it is that there isn't a big redundancy in the compressed air, because in our technology you might not need an additional compressor. Of course, they always need to have a backup compressor, but you don't need to have as many backup compressors as with the screw compressors. There's a question: do we need to provide internet access? No, our compressor has a modem. It has a 3G modem, so we provide the modem and the connectivity to the compressor. If you need to integrate our compressor to the factory, let's say upper level system like SCADA or some other system, we do have very open interfaces. So we have the most common bus, Profibus type of this connection availabilities or things as a standard, so you can use them as a standard, and then we have analog connections as well as a standard in the unit. So the connectivity of the unit inside of the factory is very high, and we are happy to provide all of the information we have in our compressor to the factory. And you can actually through the remote monitoring or through the connection, we also have a cloud system where you are getting access to the compressor's operational data, also including the dryers and whatever flow meters we have installed with the compressor into the compressor room. So all of that is available for customers to use. If there are no more questions, did I answer all of them? Yes, I have answered all the questions. If there are more questions, please do take contact, or there's still 1 minute to type them in the box. If not, then I sincerely thank you for taking the time to listen to this technology and this story. I hope to hear from you if you have concerns or opportunities. We are happy to help you save the world and save some money.